Welcome to This Explainer. Today, we are completely untangling the alphabet soup of microeconomics. We're going from the deep philosophical definitions of what a cost actually is straight into the mathematical curves of a firm's daily operations. Whether you're looking at a single business or the broader impact on society, understanding these mechanics is absolutely essential. Here's our roadmap for today. We'll hit the true cost of business, private versus social costs, short-run cost basics, the shape of total costs, average and marginal costs, and wrap up with revenue basics. Let's get to it.
Part 1. The true cost of business.
So, when a business opens its doors, what actually is a cost? Most folks think it's just money leaving a bank account, right? Writing a check for rent or payroll. But true economic cost? That is the sum total of both explicit payments and implicit sacrifices. And crucially, this includes normal profit. That's the minimum payment a producer absolutely must receive just to be induced to take on the risk of production. It's essentially the salary the entrepreneur has to pay themselves to stay in the game rather than doing something else.
Think of business costs like a massive iceberg. The visible tip is really just a fraction of the story. If you're only paying attention to what's above the surface, you are missing a huge, dangerous piece of your financial reality. Up above the water, you've got explicit costs. These are your direct, out-of-pocket money payments, paying salaries, renting a building, buying raw materials. Basically, your accounting costs. But lurking down below the surface are implicit costs. These represent the opportunity cost of using the firm's own resources. Like if an entrepreneur uses their own land to build a factory instead of renting it out, well, the rent they gave up, that is a very real implicit cost.
Section 2. Private versus social costs. Let's step outside the factory walls for a second and look at costs through a wider societal lens. A firm naturally calculates its private cost, which, as we just established, is its explicit plus implicit economic cost. It's the bottom line for their own decision-making. But the social cost is often way larger because it tacks on the burdens placed on the rest of society, what we call external costs. For instance, think about an oil refinery polluting a local river or a massive factory pumping heavy smoke into the air. Those are external costs. Society is footing the bill for those impacts through their health and their tax dollars, not the firm. And that's exactly why governments usually step in with regulations. Moving on to Part 3, short-run cost basics. All right, let's step back onto the factory floor and set the rules for the short run. In economics, the short run just means a period where at least one factor of production is completely locked in or fixed. You can't just magically construct a new factory building overnight, right? That capital equipment is your fixed factor. But your variable factors, things like hiring casual labor or buying extra raw materials, those can easily scale up or down depending on your desired level of output. Section 4. The shape of total costs. Let's translate these short-run inputs into the macro view of the firm's total costs and see what happens when we actually run the numbers. The formula is beautifully simple. Total cost is just the sum of total fixed cost, which, remember, absolutely never changes no matter how much you produce, plus total variable cost, which goes up as you ramp up production and use more materials and labor. What's really fascinating here is how the geometry perfectly maps back to that algebraic formula. You can visually see how the fixed and variable components stack right on top of each other to create the firm's total financial burden. Let's break this down step by step. First up is that totally flat horizontal line for total fixed cost. Notice how it starts high up on the vertical axis, proving that even if you produce absolutely nothing, zero output, you still have to pay the rent. Second, the total variable cost curve starts at 0 and bends upwards as output grows. And finally, look at the total cost curve. It doesn't start at 0, it kicks off exactly at the fixed cost line. The whole TC curve perfectly mimics the exact wobbly shape of the TVC curve. And the vertical gap between them, that's always exactly the amount of your constant fixed costs. Section 5. Average and marginal costs. We've looked at the macro picture, so now let's hit the climax of our explainer, the per unit micro view. This is where things get a bit tricky for people, but it's actually incredibly logical. When we divide our total costs by the number of units produced to get the average cost, the curve almost always forms a very distinct U-shape. But why does this happen? Well, it's not just random math, it's physics and operational reality. The law of variable proportions dictates that as you keep throwing variable inputs, like more workers, at a fixed input, like a single machine, you'll eventually hit diminishing returns. At first, average costs fall because you're getting more efficient, but soon enough, the space gets crowded, efficiency drops, and average costs are forced right back up.
Watch how the average total cost, or ATC, and the average variable cost, AVC, behave as output increases. You'll notice the gap between them gets smaller and smaller. Why? Because that vertical gap is your average fixed cost. As you pump out more and more units, that fixed rent is getting spread thinner and thinner across a much larger volume. This drives that specific per unit cost down, pulling the two average curves closer together, even though mathematically they can never actually touch.
And here is the absolute golden rule of cost curves. The marginal cost curve, which tracks the cost of producing just one additional unit, will always intersect the average cost curve exactly at its absolute minimum point, from below. Think about it. If the cost of your next unit is cheaper than your average, it drags the average down. If it's more expensive, it pulls the average up. So they absolutely must cross exactly at the very bottom of the U.
Which brings us to our final part, Section 6, Revenue Basics. We've thoroughly mapped out how money leaves a firm. Now let's look at how it comes back in. This is a masterclass comparison, because revenue completely transforms depending on the market structure. Let's imagine a massive split screen. On one side, perfect competition, where a firm has constant prices. On the other, imperfect competition, where a firm has to drop prices to sell more. Now, total revenue is simply your price multiplied by quantity. In perfect competition, with constant prices, your total revenue is a perfectly straight upward sloping line. But in imperfect competition, because you have to constantly lower your price to move more units, that total revenue curve bows outward into a hill-shaped concave curve.
Next is average revenue. This is what you make per unit, which algebraically simplifies straight back to just the price. Under perfect competition, since the price never ever changes, your average revenue curve is a perfectly flat horizontal line. But under imperfect competition, as those prices drop, your average revenue curve slopes straight downward.
Finally, marginal revenue, which is the extra income from selling just one more unit. To complete our split screen showdown, in perfect competition, because the price is completely flat, marginal revenue perfectly overlaps your horizontal average revenue line. AR literally equals MR. But in imperfect competition, marginal revenue doesn't just slope downward, it absolutely plummets, falling twice as fast as average revenue.
This leaves us with a truly fascinating puzzle to ponder. We know the marginal cost curve eventually rises sharply because of the law of variable proportions. So as a business scales and pushes its production to the absolute limit, how long can it outrun those U-shaped cost curves before the math catches up with the profits? Can technological innovation shift these curves entirely downward, totally redefining the short run? It's the ultimate balancing act of business logic. Thanks for joining me on this explainer, and keep questioning the curves.